All right, good day. So in this video, we're going to be continuing with your Euclidean questions from your 2022 paper. Now, question 13 is an integration of both your grade 11 Euclidean as well as your grade 12, right? So here we are given the diagram, right? Now, okay, this is the circle. Now here, A, B, and AC are tangents. Now remember, these are tangents from the same point. And what do we know about tangents of the same points? They are equal to one another. All right. Now here we are also told about perpendicular lines. All right, fine. So now let me see what the first question is requiring from me. Prove that triangle FEB is similar to triangle FGC. Now let me highlight my triangle FEB. So this is my F to E. Now, my other triangle, which I'm going to highlight with a different color, FGC. Now, I need to prove that these two triangles are similar to one another. All right. So using the information that I'm given, can you see that here I'm given B1 as well as this angle here, right? So angle F, basically, it's not necessarily represented, right? So here, for example, here on your angle F, it's not written whether it's F1 or F2, meaning that if I could prove that these two angles that I'm given are equal to these other angles that I'm given in this triangle, which are these two to be specific. So now let me go about proving. Now, first, I can see that my angle E2 is equals to 90 degrees as well as my angle G1 with the orange triangle, right? Angle E2 is equals to angle G1, and they are both equals to 90 degrees. And this was given. Right. So remember, normally you would need to prove that three angles are equal in these two triangles, right? But as I've just indicated here, we are given angle E2 and B1 in the blue triangle, and here in the orange triangle, we have C2 and G1, right? So you're only going to prove those angles which are represented in terms of numbers. So with regards to F, we are not told which one is F1, which one is F2. So as a result, we won't do that. So now for the other two angles that are equal to one another, so let me see. So if I look at my FB, right? FB is a chord, right? Now FB, let me try and separate this here. So this is F to B, which is a chord, right? F to B is a chord, right? So this is my chord, and I have a triangle, and this is my triangle that is formed. This is my point C, right? So let me just try and represent that chord. So this would be my circle where it passes. So this is a chord, right? And I also have my tangent, right? So my tangent, let me draw my tangent. It passes through a point B. So I'm just going to put it here. Yeah, let me put it here, right? So as a result, remember your tan chord theorem, right? So this angle between your tangent and your chord is going to be equals to the opposite interior angle of your triangle, which is that angle right over here, right? Now, what is this angle right over here? This is our angle B1, and this, as a result, is our C2. So here, B1, which is in the blue triangle, it is equals to C2 in the other triangle. And why is that? Tan chord theorem. Now, because these were the only angles that we had in the blue, E2 and B1, and these are the only angles we have in the orange, C2 and G1. So therefore, we can conclude that the two triangles are going to be similar to one another, right? So remember, the reason why I'm not proving my F's because I'm not given, my F angles are not numbered. So triangle FEB, it's similar to triangle FGC, and my reason would be angle, angle, angle. Right. Now I've proved that those two triangles are exactly the same. Now, last question, prove that FG squared, right? It is equals to, so let me write this here near the sketch. So FG squared, it is equals to FE multiplied by FD. Multiplied by FD. All right. Now, let me just try and erase here and try to solve for the question. Now, let me see if I could do that using the previous question which I've did before, right? Basically, my previous answer. Now, remember, if these two triangles are similar to one another, I can use ratios here, right? So basically, what do I mean by that? So in the two triangles, so I'm going to say, okay, in triangle which are similar to one another, FEB and triangle FGC, right? I'm gonna use ratios for the two triangles, right? So now how would I go about doing that? So I'm gonna say, okay, FE, right? And I'm also gonna choose a similar side to my FE. So FE over similar side on the other triangle is FG, right? So this is my FE, another similar side to it, it will be of G. This is equals to, let me choose another two sides which are similar to one another. So this is equals to, let me see the other sides that are similar here. So my FB, which is my hypotenuse, also my hypotenuse this side is going to be FC. So here I can say FB over FC, and the last remaining sides which are common, I could use EB. So this would be EB over GC. All right. So now I'm trying to prove that FG multiplied to FE, right? FG squared is equals to FE multiplied to FD. Now let me see if I could be able to derive that ratio from what I have here. All right. So I could see that, okay, I have FG here, I have FE here, right? So I can choose this one, FE over FG. But the only thing I don't have here, it is my FD. Now, how will I go about finding my FD? It means that I need to use, I need to prove the other triangles that are similar to one another, right? I need to prove two triangles that they are similar so that I could get the FD that I'm looking for, right? Now, how would I go about doing that? So what are the other triangles that we have here in this diagram, right? So let me just try and erase here and highlight those two triangles that I'm going to prove that are similar. So here I have triangle FDC highlighted here. So this is my triangle, right? As a result, I'm going to prove that this is similar to this triangle, right? Because why? These this triangle here has the line that I'm looking for, right? Remember, what is that line that I'm looking for? I'm looking for my line. So let me see here, FD, right? FD is in this orange triangle. So I'm going to try and use similarity in these two triangles, right? So now doing so, so I'm going to first start with writing the two triangles that I'm dealing with, right? So it's triangle FDC and triangle. So the other triangles, so it's FDC and triangle FGB. All right, now I need to prove that using these angles that I have, right? Can you see two angles in each triangles, they are named. So here I'm going to say, okay, D2, here it's equals to this angle, which is G2, and they're both equals to 90 degrees, and this was given, right? Now, our other angle that we have, right? So the other remaining angles, so these are equal. Now, if you see that FC, right, this line from F to C, it's basically my chord. So this line here, it's my chord. And what do I know about this angle here? Right. So your angle, in accordance to the tan chord theorem, the angle between your tangent and your chord is equals to the angle in the interior. So it will be equal to the interior angle of a triangle, right? Basically the opposite interior angle of your triangle in this case, which is B2, right? So here, C1, it will be equals to B2, and or rather our reason here, it will be tan chord theorem. So as a result, we prove these two angles, we are given both triangles that they are equal. So as a result, we can say triangle FDC is going to be similar to triangle FGB. Now we can use ratios to find the ratio that we're looking for. Now our reason here is going to be angle, 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 right? Now let us try and do ratios on the two triangles right over here. So here, okay, let me choose similar sides. So here I could see, I'm going to start with my line. So I'm going to say, okay, FB, right, which is my hypotenuse, and my hypotenuse on the other triangle here, it's my line FC, right? So FB over FC, and this is equals to, so let me see here, I could say FG, right? FG over FD in this instance, so FG the side that is similar to my FG on the other triangle, it's FD. And lastly, I have my line GB, and the side that is similar to GB in this triangle, it will be my line DC. And my reason here, I would name, or the reason for this, I would say triangle FDC, remember, is similar to triangle FGB. Now, remember, I said the ratio that we must choose, right? In this instance, it must have both FG as well as FD, right? Now, this is the ratio we're going to choose. And if you could see here, our FG over FD, this is equals to FB over FC, right? In accordance to that. And same applies here to our FE over FG. Our FE over FG is equals to FB over FC. Now, as a result, I can then equate the two. I can now say in conclusion, FE over FG, this it's equals to my FG over FD, right? Because both of them, they are equals to FB over FC. So now I'm going to cross multiply. And if I do so, this is going to be FG squared. This is equals to FE multiplied to FD. And this would be your final answer, right? Now, that will be all for this video. Remember, if ever you have any questions, always feel free to reach out. Thanks.